Another example. We start with a parametric curve given to us by, say, x equals to cosine t, y equals to sine squared t, where t is between 0 and 2 pi. And as we did before, we want to identify and sketch the graph of the curve. Identify and sketch the graph of the curve. As we did in the previous case, we notice that we have x equals to cosine t, y equals to sine squared t. So we notice that we have cosine and sine. So immediately we want to think about the main trig identity, which will say cosine squared plus sine squared equals to 1. So let's write it down. The main trig identity says cosine squared t plus sine squared t equals to 1. Sine squared is y. Sine is x. So from here we're going to get x squared plus y equals to 1. So we're going to get y equals to 1 minus x squared. And we can easily identify this curve as a parabola. So we can sketch its graph for a parabola. Vertex x equals to 0, y equals to 1, upside down parabola. So y equals to 1 minus x squared. That's a first observation. Now we have to be careful with our parametric curves. Even though, yes, we got y equals 1 minus x squared, but if we again look what is x, x is cosine t. So just looking at that expression, x equals to cosine t, we know that x is bounded between -1 and 1. Because x is cosine t, and cosine is between -1 and 1. So what we have here is, we're not looking through the whole parabola y equals 1 minus x squared. We cannot pixel it, where y equals to 1 minus x squared, but x is between -1 and 1. Actually, we can do a little bit more. We can see that y equals to sine of t squared. So from here, we can going to get that y should be at least 0 and at most 1. Getting all that information, now we can improve, keeping that information in mind, we can improve our answer, and we'll say that our answer is going to be the piece of our parabola between these 2 points, the one which is shaded red. That's going to be our answer. So our answer is a piece of parabola y equals 1 minus x squared for interval of x between -1 and 1. So if we have x equals to t plus 1, y equals to 2t plus 3. So we have parametric curve, and we want to identify sketch a graph. So what we'll do in this case, we'll start with a parametric curve. That's what we started with. If x is f of t, y is g of t. What we'll try to do is, we'll try to get a regular curve, a regular function y equals f of x from here. So what we try to do is we will do so-called elimination of parameters method. So what we'll try to do, if possible, we solve one of the equation for t. So we solve for t, and we're going to substitute into the other equation. If we're successful in doing that, parameter t will disappear, and we're going to have only one parameter, y as a function of x, where we're looking at parameter t. So let's try. So in our case, we have x equals to t plus 1. We can easily solve it for t. So t equals to x minus 1. So we did that to the first equation. Now we look at the second equation, which says y equals 2t plus 3. So we're taking that expression, t equals x minus 1, from first equation, and we're going to substitute it into the second. So we're going to add y equals 2 times x minus 1 plus 3. And that is our regular function y is a function of x. So if you like, we can simplify it, distribute 2, combine like terms. So we're going to get y equals 2x minus 2 plus 3. So y equals 2x plus 1. And we can easily identify that curve. That is a straight line. We can sketch a graph. Slope 2, y-intercept 1, so it should be a little more or less straightforward, something like that. So that's a graph of y equals 2x plus 1. This is a graph of original parametric curve.